Hey folks, since in the last session what we have done is, we have built our logistic regression model and we have computed how well the model is performing. Along with that, we have also find out its confusion matrix. That's what we have done, especially in the previous session. So in this session, our fun challenge is all about, let's try to automate all the predictions that you have. So in a nutshell, this problem statement is all about, hey, can you define some function? Let's say f1. And the moment I pass the machine learning model, let's say m1, we will end up getting all the stuff like, hey, what is the accuracy score? What is the accuracy score of my m1 model? Doesn't matter what this m1 model is, whether this is random forest, whether this is decision tree, whether this is XGBoost, whether this is SVM, whatever model, doesn't matter. You have to print all the stuff. Let's say, hey, what is the accuracy score of m1? Or let's say, hey, what is the training score of this m1? In addition to that, you can also think of something known as, hey, what is the confusion matrix? Plus, what is the classification report, where you will end up getting the recall, the precision, the f1 score, tons of things, stuff like that. Again, for those of you who do not know all these algorithms, I extremely recommend you just to check out the previous videos with respect to all the algorithms that I have uploaded. So let's try to define that function. So what I will say is, I will say, hey, let's try to define a function. Let's say function name is all about, let's say predict. So whatever machine learning model I will pass to this function, it will return the accuracy score, training score, precision, classification report, and stuff like that. So whatever model we have, so I will say ML underscore model. First and foremost, I need to perform the training on top of that model. So I will say, hey, x underscore train, comma, y underscore train. Look at this. Let me show you that. This is what you have done with respect to your logistic regression. Once you will do your training, then you have to do something known as prediction on top of your data. So I will say, hey, let's try to do the prediction. So I will say, let's store this training in model. So using this model, you can call something known as predict. So I will say model.predict. Sounds good. Now, whatever prediction you will get, let's say this is my pred, or let's say y underscore prediction, whatever else you want to name it as. I will say y underscore prediction. Cool. Again, if you want to print the training score, I can say, let's say print. Now what we have to print, let's say we have to print our training score. So I will say training score is all about nothing but I have to add this placeholder and I will receive the value of this placeholder from my format function. Sounds good. So just to get the score, I can think of calling something known as score, which is an inbuilt function of my scikit-learn module. So I will say x underscore train. Oh, my bad. It is x underscore train. The moment I pass, oh, it is, I think, x underscore train. Let me cross check. Yeah, it is uppercase. Sounds good. It is uppercase. Let me press tab. And here I will say y underscore train. Now, whatever prediction I will get, what we have to do is, let's say we have to print all the predictions. So I will say predictions are nothing but, let's try to add this placeholder. Let's receive its value from my format function. So I will say format is all about nothing but y underscore prediction. The moment I press tab, sounds good. And just to make the stuff more user friendly, you can think of adding a new line. So I will say /n. Then what you will do is, you have done all this stuff. Now you can think of printing the accuracy score. So what I will do is, I will say, hey, what is the accuracy score of the model? So I can think of just using this accuracy score. Here we have to pass our y underscore prediction and what is exactly my true values, which is exactly in my y underscore test. Now I will say, let's try to print it. Let's try to print the accuracy score, whatever you have. Sounds good. Along with that, you can also think of printing something else. Let's say, what is the confusion matrix? So I will say, whatever confusion matrix I have, this is my confusion matrix. Inside this, I have to pass something known as y underscore test, along with whatever prediction you have, which is exactly my y underscore prediction. So let us store this matrix, let's in CM, and let's print the CM that you have. So I will say CM is nothing but this one. Let's try to add the placeholder and let's receive the value for my placeholder using the format. Sounds good. In this, I have to pass this CM. Just to make the stuff more user friendly, you can say this is exactly my confusion metric, so that you guys will not get confused. Sounds good. You have print all this stuff. Again, if you need to print some other stuff, let's say, hey, what is the classification metric? So what I will do is I will say from this scikit-learn dot matrix, you can think of importing something else which is all about classification report. Sounds good. Let me remove it and let me execute this line of code. And let's try to initialize this classification report, because I need the classification report of my entire model. So I have to very first pass the true data, which is exactly my y_test. And then we have to pass all the predictions that we have. I will say this is exactly nothing but my y_prediction. Just press tab, just select it. And let's store this report in, let's say, REP variable. Let's print the report. So I will say report is nothing but just this placeholder. Let's receive this value of this placeholder using my format. So I will say it is all about REP. Now let's execute these lines of code. And if I'm going to say, hey, can I call my function, which is all about our predict function? Let's press tab. This is exactly that predict function, which is all about this one. And over here, we have to just pass our machine learning model. Let's try to cross check this, let's say with respect to logistic regression. The moment I pass LR and the moment I will execute this line of code, now you will see the magic. The training score of your model is this much. These are all the predictions that you will end up getting. This is exactly the accuracy score. This is exactly the confusion metric. And this is the entire report that you have. As it is a binary use case, you will end up getting two subcategories. And this is the precision score, this is the recall, we have F1 score, we have some support value. So these are typically just on account of the function that you have defined. Similar stuff if you want to do with respect to random forest, you can do it. So what I will do is I will say, hey, from this scikit-learn.ensemble, let's import something known as random forest. So I will say random forest classifier. Sounds good. Let's initialize the random forest classifier. And let's store this object, let's say in RF. Let's execute this line of code. Let's call this predict function. Let's pass this RF over there. Let me execute this line of code. Now you will see its training score is 1. Amazing. Predictions are that much, but unfortunately your accuracy gets a drop depending upon the training score that you are getting. Similarly, this is the confusion metric that you will end up getting. This is a report of the entire model that you will end up getting. Now let me show you one more crazy thing. The moment I press Shift plus Tab over there in my random forest classifier, look at all the parameters that we have. Look at the parameters that we have. So we have a data, which is exactly my data frame object. On top of this, we have applied this random forest with all the by default parameters. These are exactly my by default parameters. But let's say here my value is, let's say 2, minimum sample split, let's say 2. Let's say criterion, which is all about the Gini. It means what metric or what approach, what strategy he has to use just to build the decision tree. That's what criterion does. And estimate is 100, which is all about the number of decision trees you need in order to build a random forest. But it is not necessary that whatever default values you have, that suits best for this data that you have. So in such case, just to find the optimal value of each and every parameter, let's say we have P1 parameter, we have P2 parameter, we have P3. So just to obtain the optimal value of each and every parameter that you have, you can think of something known as a concept, often known as hypertuning. You can just tune the parameter that you have. Again, at some instance, you have heard about, if you are someone who have learned machine learning from some other places, you have heard about something known as hyperparameter optimization. It means there are some parameters in the algorithm that you have that you can think of hypertuning it just to obtain the optimal value of those parameters. That's what actually this hypertuning or hyperparameter optimization stands for. Again, in the next module, we will touch upon what exactly the hyperparameter optimization, what are all the techniques just to obtain the optimal value of all the parameters. In addition to that, we will implement all this stuff, of course, using line by line explanation. So that's all about the session. Again, for those of you who have any doubt, feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.